This is the last video for Module 9. The last topic in the book is about polar and covalent molecules. Now that means, again, polar and covalent molecules mean that they're covalently bonded compounds. Now, remember when I talked about electronegativity and how important it is? We can use the property of electronegativity and we can predict if something is covalent or ionic, and if it's covalent, if it's polar or nonpolar. Dr. Wiley has how to determine polarity. I'm going to show you something even easier. The whole thing with electronegativity, remember we said was an invention. Linus Pauling, an academic, invented it. His original electronegativity chart was from 0.7 to 4.0. Like the scale, like a grading scale. When you convert F's and A's, an F converts to a 0, and A converts to a 4.0. Okay, so right here, lithium is just about 1. This is 0.7, 4.0, 3.5, 3.0. This is 2.5, 2.1. Those are some of the key. On the blog, you're going to see that I have a chart. Pull that chart up. Now, so what we're going to do is let me show you then how we determine whether it's polar or nonpolar. What we do is we use electronegativities. Let's start with H2O. Okay, so here's our molecule. We're looking at the bond. Now we have 2 OH bonds. We have 2 of those here. Okay, so I want to know what the electronegativity is for oxygen. So remember we said electronegativity, it's increasing as we go from left to right. It is decreasing as we go down the column, down the group. Okay, so fluorine is 4.0. The second most electronegative is oxygen, it's 3.5. Hydrogen is 2.1. So 3.5 and 2.1. Remember, this is a scale. How well does it grab electrons? So how do I figure out whether this is polar or nonpolar? I subtract it. Okay. The difference between, and each one is 2.1. Each bond is the same. The difference in electronegativity is 1.4. Okay? This is the cutoff. If the difference is 1.5, sometimes you see 1.6, but this is 1.4. That means it's less, right here, it's less than 1.4, and it's polar. As you read in the book, water is a polar bent molecule. You already know that. Now, but let's look at instead, let's look at another one. Let's look at CH4. Carbon, this is methane. CH4 is methane. Now, carbon is 2.5, and we already said hydrogen's 2.1. The difference in the electronegativity is 0.4. Now, notice where that puts it. So it's definitely covalent. This 0.5 is the cutoff between nonpolar and polar covalent molecules. So because the difference is 0.4, carbon tetrachloride is nonpolar. All right, let's just do one more of those. Let's do CO2. I'd have to do the Lewis. I think this is correct for the Lewis step, for the line diagram. Okay, this is 3.5. This is 2.5. What's the difference between 3.5 and 2.5? 1.0. So what kind of molecule is it? Okay, if it's less than 1.5, it's a covalently bonded molecule. Okay, if it's between 0.5 and 1.5, 1.0, it's a polar covalent molecule. So while Dr. Wiley shows you one method in the book, instead I'm showing you how to use the difference in electronegativity and we can determine whether it's polar or nonpolar. The other thing I wanted to bring up is Linus Pauling originally, his scale was, again, academic 0 to 4.0. You're going to see other scales for electronegativity. Some of those are slightly different. For instance, they may give fluorine 3.98 instead of 1.0 for lithium. It might be 0.98. There's different scales. There's all different theories. I like to use his original work because it makes sense, because it's based on a grading, a whole grading scale. And that's it. That's it for Module 9.